Hi, I'm David Mueller, retired hydrologist from the U.S. Geological Survey, founder of Genesis Hydrotech, and developer of QRevMS. With the release of QRevMS version 1.24, QRevMS now supports processing data collected with the SonTek FlowTracker and FlowTracker 2. Note that the latest release as of the making of this video is version 1.29. This training video will cover only the differences in user interface when processing data from a FlowTracker compared to an ADCP. For complete training on QRevMS, please refer to other videos in this series. To load data from the original FlowTracker, you must first open the FlowTracker software. Make sure the options to export the DIS, CTL, SUM, DAT, and put header on ASCII files are checked. Then open a FlowTracker file. Once the file is opened, ASCII files are created. You may then close the FlowTracker software. To load the original FlowTracker data into QRevMS, you can click the Open Measurement icon and select the DAT file. QRevMS requires the DIS, CTL, and SUM files to be in the same folder with the DAT file and will automatically load all 4 files. For FlowTracker 2, QRevMS supports loading the raw FlowTracker 2 FT file directly, and there is no need to open the FlowTracker 2 software and create additional files. Simply click the Open Measurement icon in QRevMS and select an FT file. Upon opening a FlowTracker file, you will notice that the velocity reference and azimuth options are absent from the toolbar as they do not apply to FlowTracker data. The Compass PR tab has been renamed to Tilt, and the bottom track and extract tabs are inactive. In the table, the velocity method now indicates the point measurement method used to compute the mean velocity in each vertical, and perhaps the most obvious difference is the adaptation of the color contour plot at the bottom to point velocity measurements. The color contour plot displays a square at each measurement point colored based on the measured normal velocity for that point. To change the selected vertical, you can click in the table, in the percentage discharge bar graph, or on a point in the color points plot. The extrapolation plot at the middle right will show the ensemble data in gray and the mean in a black square for each measurement location in the vertical. The green power fit is not used in the computation, but is a representation of what a continuous power profile would be with the same mean as the mean velocity computed from the point measurements. QRevMS supports most common point velocity methods, including 1-point methods, 0.6, ICE 0.6, and ICE 0.5, 2-point methods, 0.2 and 0.8, the Krebs method, and ICE for 0.2 and 0.8, the 3-point method, 0.2, 0.6, and 0.8, a 5-point method, 0, or surface, 0.2, 0.6, 0.8, and 1, and a 6-point method, 0 or surface, 0.2, 0.4, 0.6, 0.8, and 1 or the bottom. For ICE measurements, the ICE correction factor is read from the FlowTracker data files, but can be edited on the WaterTrack tab. The Details tab displays multiple rows for each station. The first row for a station contains the values for the station, while the subsequent lines for the station contain the measured data at each fractional depth. The Pre-Measurement tab indicates if an automatic beam check was completed and if there were any issues. The meter and user temperature are also displayed. The user temperature must be entered in QRevMS as it is not supported in the FlowTracker as a comparison measurement. The Setting tab contains the mounting correction and the threshold settings for the filters. The mounting correction is a correction factor that accounts for a bias in the velocity measurements caused by flow disturbance from the mount and weighting rod. The default is 0. Before I discuss the other tabs, I will describe the filters and associated thresholds. The SNR filter is applied in two ways. First, the SNR must meet a minimum threshold. If any of the beams have an SNR below the minimum threshold of 4 dB, the measured velocity for that ensemble or sample is marked invalid. If the SNR is less than 10 dB, the user is given a caution message, and less than 7 dB, the user is given a warning message. Second, the SNR must be consistent between the beams. If the difference in SNR between the two beams is greater than the SNR threshold of 10 dB, the measured velocity sample is also marked invalid. The random uncertainty of the velocity is computed for each vertical. If that random uncertainty exceeds 25%, a warning is issued, and if it exceeds 10%, a caution is issued. A high random uncertainty indicates that a longer sampling time is required to obtain a good average velocity. The spike filter is an implementation of the FlowTracker 2 spike filter, which is a variation of a method called the Tukey's outlier. The first quartile, Q1, which is the median value of the lower half of the distribution, and the third quartile, Q3, is the median value of the upper half of the distribution, are both computed. The difference between the third quartile and the first quartile is called the interquartile range, or IQR. These values are then used to compute the filter window. The maximum window is the third quartile plus a multiplier times the interquartile range, and the minimum of that filter window is the first quartile minus the multiplier times the interquartile range. The multiplier defaults to 2. Spikes are removed from the computation of the mean velocity at the measurement location prior to computing the mean for the vertical or the point location. The FlowTracker is designed to be held perpendicular to the tag line. However, the flow may not be perpendicular to the tag line. If the flow is at an angle, the probe may cause a flow disturbance in the measurement volume, resulting in an inaccurate velocity measurement. If the flow direction is greater than 45 degrees, QRevMS will issue a warning message. And if the flow is greater than 20 degrees, a caution message is issued. The original FlowTracker does not provide tilt data, but the FlowTracker 2 provides the mean, max, min, and standard deviation of the tilt, which is a combination of the pitch and roll of the probe. Tilting the probe or not holding it steady could introduce errors in the velocity measurement. A tilt greater than 10 degrees will cause a warning to be issued. A tilt greater than 5 degrees results in a caution. If the standard deviation exceeds 1 degree, a caution is issued indicating the probe was not held in a steady position. The Instrument tab provides the serial numbers and firmware versions of both the probe and handheld parts of the FlowTracker. The model of the FlowTracker is also provided. If only FT is shown, it is the original FlowTracker. Finally, the Message tab contains any messages related to the information on the main tab. The System Test tab shows the results of an automatic beam check. For the FlowTracker 2, in addition to the reported results, a graph of the beam return signal is also presented. The Tilt tab is only active for FlowTracker 2 measurements. The tab contains a table showing the mean, maximum, minimum, and standard deviation of the tilt for each vertical and each point measurement used in that vertical. There is also an option for the user to change the tilt threshold for the caution message. The temperature salinity tab is unchanged, and the temperature time series represents the measured temperature for ensembles at each point measurement location. Clicking in a row in the table will highlight that vertical or point locations data in the graph. The Stations tab is unchanged except for adapting the color contour plot to point velocity measurements. The Depth tab is simpler than it is for a profiler. Typically, for a FlowTracker, the depth is entered manually. Some FlowTracker 2 meters have a pressure sensor for measuring the depth. However, whether manual or via the pressure sensor, only one value for a depth is provided for each vertical. Thus, the top graph is simply a straight line. The bottom graph displays the cross-section profile with the selected vertical indicated by a circle. The user can edit the depth and/or depth source using the controls at the top right of the tab. The Water Track tab has been adapted to show the data necessary to evaluate the quality of the velocity measurement made with a FlowTracker. The table at the top shows the station number, location, and data for each fractional depth at a location. The filter results and mean velocity data are shown for each vertical, and below that vertical for each fractional depth measured for that vertical. The two time series graphs on the lower left show the data for the individual ensembles that are used to compute the mean velocity and the associated SNR values. The data presented in these graphs change depending on whether a vertical has been selected or a fractional depth has been selected. If a vertical is selected, the top graph shows the normal velocity time series for each fractional depth. The thin line with dots represents the velocity for each ensemble, and the thicker line shows the cumulative average of those data. Red circles indicate data that were determined to be invalid based on the spike and SNR filters. For a selected vertical, the bottom graph is similar, but shows the ensemble and cumulative mean SNR data. If a row in the table containing a fractional depth is selected, the data in the time series graphs are for each velocity component or beam. For the top graph, the x velocity component is shown in red and the y velocity component is shown in blue. Again, the thin line with the dots shows the individual ensemble data, and the thicker line the cumulative average of those data. Similarly, the bottom graph shows the ensemble and cumulative mean SNR for each beam. The graph on the right shows the velocity magnitude and direction profile, or the profile of the SNR. The controls on the right allow the user to change the velocity source and enter a manual value or change the filter settings. For the spike filter, the user can change the multiplier, which defaults to 2. For the SNR filter, the user can change the minimum allowable SNR below which the data are marked invalid. Finally, if the user knows that their mount and weighting rod creates a known bias in the data, a correction factor can be entered or changed. The Edges tab remains unchanged except for the color contour plot being adapted to point velocity measurements. The Uncertainty tab is also unchanged. That concludes this video of the use of QRevMS with FlowTracker measurements. If you have questions or comments, you can leave them in the comments below or contact me through the information on the web page.